Today, we'll be creating this firebolt projectile using UE5's Niagara VFX system. This effect is split into two emitters, the leading capsule and the trail. You can get all the assets for this tutorial from the link in the description. Let's get into the action. Create a new empty Niagara system. Name it NES_projectile_fireball and open it up. We'll start by creating our projectile's leading capsule emitter. Right-click in the system graph, create a new emitter using the single looping particle template, and name it NE_projectile_capsule. Then set this emitter's local space flag to true in its properties. This way it moves around with our system in real time. Then replace its sprite renderer with a mesh renderer, and set its mesh to be this capsule, which you can download from the link in the description. Note that you can easily create your own using any 3D modeling software such as Blender. Now enable material overrides and add an instance to the override material array. For this material slot, we'll be using this animated Niagara material which we created in this previous tutorial. Now, in the content browser, right-click this material and create a material instance, then name it mi_add_scrolling_projectile capsule. Now open up the material editor and override the main texture to be this projectile texture. If you wish, you can create your own texture for this using any 2D painting software, such as Photoshop. Save this material instance, and then back in the Niagara system, set the first index of our projectile to be this new material instance. As we want to be able to customize the scale of our projectile on a per instance basis, we'll create a new user exposed float parameter and name it scale. Then we'll set its default value to 1 in the blue system node. Now in our emitter's initialize particle module, set its mesh scale mode to be non-uniform. Then select the drop-down arrow to the right of this vector and search and select the multiply vector by float. Set the float to be our scale parameter and the vector to be something like 0.65, 0.65 and 0.85. Next we'll add an initial mesh orientation module to the particle spawn stage of our emitter. We'll set the mesh orientation mode to none, its rotation coordinate space to be local, and then set its value to 0.25 in the y-axis. This way our capsule will point forwards in the x-axis. In order to add color to our effect, we'll create two user-exposed linear color parameters, naming them capsule color 01 and capsule color 02, setting their default values to red and orange. Then in our emitter's initialize particle module, we'll set its color mode to be a random range and set the minimum and maximum to be the two parameters we just created. If you've watched our tutorial on creating this animated material, then you know that we can add a dynamic parameters module to our particle spawn stage in order to directly control the dissolving and distortion of our animation. In our case, we'll set the distortion to 0.2 and the dissolve to 1. If you wanted to make the projectile lighter, then you could increase the dissolve amount. Next up, we'll create the trail emitter for our projectile. To do this, right-click in the system graph, create a new emitter using the static beam template and name it NE_projectile trail. Then set its local space flag to true in its properties. Now delete the color module, set the emitter's lifecycle mode to system, and in the initialize particle module, set its lifetime to current loop duration. Then set its color to be the value of a new linear color parameter named trail color 01. We've defaulted this to have the same color of our capsule color 02 parameter. As you can see, our trail is currently rendering from the center of our simulation and to the right. However, we'd like this to be offset behind our capsule and to scale correctly on a per instance basis. To do this, open the beam emitter setup module and change the beam start to be a multiply vector by float function. Then set the float value to be our scale parameter and the vector to be 90 in the x-axis. What we've done here is move our beam to start near the endpoint of our capsule. However, you can see it's currently rendering in the wrong direction. This is because the beam end value is still set to 200 in the x-axis. To fix this, change this vector to be a multiply vector by float function, setting the float to our scale and the vector's x value to something like -350. Now that our trail is appearing in the correct location, let's set its material in the ribbon renderer module to be an animated material. As we did before, let's create a material instance of our animated material and name it something like mi_add_scrolling_projectile trail. We'll then open this up in the material instance editor. Set its horizontal dissolve speed to -0.4 and its distortion speed to -0.5. This way it animates towards the negative x-axis, which will give us the look and feel of our projectile flowing through the air. We'll also set the main texture to be this trail texture we created. Again, you can download this from the link in the description or create your own using a 2D painting tool. Now save this material instance, go back to the Niagara system and set the ribbons material to be this trail material we just created. As you can see, our beam is now quite small. To fix this, navigate to the emitter's beam width module and set the scale curve value to be our user exposed scale parameter. This way our beam will scale on a per instance basis. Now open up this curve to the curves panel. Set our key to have a value of 125 at the 0.05 position, then press F to bring all our keys into view. If we solo our trail, we can see that it has created this non-linear shape with our beam's width scaling as per our curve. You can play around with this to change your trail's width to whatever you want. As always, we've been your game dev pals. Hit those like and sub buttons to support the channel and consider checking out our Patreon. Tell somebody you love them, and we'll see you in the next one.